So if you look, so this yeah, here's the Algebra 2, Honors Algebra 2 homepage. So if you go down and you go to, you don't even really have to go to the resources anymore. I mean, if you do go to the resources, there's stuff there, but you can access everything from the practices. So if you go down to the practices, notice how this is kind of set up. So you got the Module 6 practices. There's going to be all the practices for a given section in the book. And then if I go down and click on something like, for example, the 6.4 resources, it'll open up a new page, and it's got links to all the resources there. And they're kind of outline form. So you can go to, like if I click on this, it opens up the textbook. If I click on this level, it's going to open up the lecture notes. If I click on any of these things, these are those little math on the spot videos from the textbook. They're short, they're good. And then this will take you to just a playlist that's only got the Unit 3 instructional video, so that's all the stuff we did in class. Okay? All right, so does that make sense? Hopefully that's helpful. All right, so I want to take a quick look at a couple things here. Let's see if you can. Do you remember what these patterns are? Take a quick look at those, and then I'm gonna see if you can write them down without looking. So remember, if we go, oops, sorry. Okay, so a couple things to kind of help you with these. Remember, there are some ways to kind of organize your thinking on this, and maybe it's a little bit helpful. The difference of squares, I think that's one you probably just know. Right? That's not a hard one. And then the sum of squares doesn't exist, right? So that's an easy one too. The ones that are harder, and you can almost skip the bottom one, you know, but rarely used. These are the two right here that we use quite a bit, and you're going to use quite a bit on the assignment. Those are the two that you're going to need to memorize. I'm not a big fan of memorizing stuff, but in math sometimes if things aren't memorized and you have to go look them up all the time, it breaks your train of thought. So these are ones you use enough that it really is worth just having a working knowledge of these. So how do we do this? If you have a sum of cubes or a difference of cubes, remember, all you got to do is you can set up the templates. Like let's do the sum of cubes. You can set up the template like this, right? And all you gotta do is, both of them are gonna be like that. So if we look at both of these at the same time, how about? A sum of cubes and a difference of cubes. The values of the sums are the same. It's just a matter of what signs go where. So what's the sign pattern in the top one? So the first one's going to match, right? Whatever is there goes there, right? And then what happens? You remember? It always flips, so it goes negative, and the last one is always going to be positive. So that one's always plus. So down here it's going to go negative, positive. Okay? And there's no 2 in front of the AB, right? All of the variables, there's no coefficients in front of any of the variables on this one. Okay? That make sense? Okay? Fill those in. Try that real quick. Get a new sheet of paper, or just don't look at it. See if you can fill all those in. Okay, when you're done, check and see if you got them. No Maisie. No Alexis. No. Matthew, Kurt, Drew, Ruby, Jesse. Okay, he's gonna be brave and come right on board.
All right, the first one.
Okay, you're on. There you go. No cheating.
No, I think it's cheap.
You just wrote it down.
I wrote them down on my paper because I did them. I think these are right. I'm not 100% on these.
Okay, good, good. So is anybody, there's a couple, just anybody spot anything they wanna, come on up. Anybody be brave.
I like to fix. To fix them.
Yeah, go ahead, I'll make it red. Go ahead and make any little changes. What? Okay, everybody agree? Okay.
No.
Well, I got some disagreement, we'll check. Katie can make her
Oh,
change.
wait, yeah, never mind.
Okay, good. Everybody agree? Anybody wanna change anything? You think? What?
There's that a squared minus ab should be a squared plus ab on the a cube plus b cube.
Which one's right? Where are you looking?
I'm looking at the second parenthesis on the a cube plus b cube.
A cubed plus B cubed.
The second quantity,
Uh-huh.
there it should be a squared plus ab.
No, it should be minus. Cause remember, it goes, whatever the pattern is, whatever that operation is copied there.
Oh.
And then it's always gonna switch. It's gonna do the opposite for the next one. Okay. Now this one right here, okay, so this is a really common mistake. Remember, a squared plus b squared, a plus b times a plus b actually gives us that, doesn't it? Right? Okay, a squared plus b squared doesn't factor. It never is gonna factor. I'll show you why. Show you why it doesn't factor. Like, let's take an example like that. Let's actually look at one we could solve. What if we had something like x squared plus 4? We're gonna set it equal to 0. And why do we factor? We factor because we're trying to solve an equation, right? Well, how would we solve this one? We'd isolate the x, right? Okay, so if we isolate the x, we'd get x squared equals, so what would x equal? So what's that gonna be? Plus or minus? Plus or minus 2i, right? Square root of negative 4. Okay, see that? Let's compare that to, I think I kind of like this part of math, seeing that things are consistent like this. What if we were gonna do x squared minus 4, right? If we solve that one, set equal to 0 and solve, we'd use the same technique, wouldn't we? We'd just say x squared equals 4, so x equals plus or minus 2, right? Well, we could have done that by factoring also. That's how I would do it personally. I don't think you really need to factor a difference in squares, because you're always just gonna set, it, if it's equal to 0, you're just gonna isolate the x anyway. But we could have factored that as x plus 2 times x minus 2 and gotten my same two solutions. How could you do that up here? Anybody know? How could we take this guy right here and factor it? Doesn't factor, right, for real numbers. Close. There is no pattern for a sum of squares.
X plus 2y, X minus 2y.
Okay, how do you, right, how do you, those are gonna be the factors, and one way you know is you can always work backwards from the zeros, right? We've already done that once. If you're given zeros, you can create the factors from those by just subtracting them from x. How could we get to that by factoring them? Could I write x squared plus 4 as a difference of squares somehow? Could I write that as x squared minus something squared?
Minus negative 4.
Or sorry,
Negative
yeah, I don't mean to put it squared yet, I just mean. Right, we could write it as x squared plus 4, we could write as x squared minus negative 4, right? Everybody see that?
Yeah.
And negative 4 is something squared. It's 2i squared, right? So that looks like x squared minus 2i squared, right? Thank you. And so we actually could factor this, right? We could factor this as x plus 2i, x minus 2i, right? We can do it. It's just that we can't do it over the set of real numbers. And I guess that's sort of implied here, but maybe I should have said that. This is one, when we go back to this page, it can't be factored using real numbers. You could actually factor it using, if you want to use complex numbers with imaginary parts, right? But for now, we're just trying to find real solutions, okay? Make sense? All right, so try, I was gonna have you do it again, but you can do it on your own. Let's try a couple of these. How about something like that? What's the pattern there? What's the only pattern it could be?
A cubed plus B cubed.
Yeah, the only one it could be is the sum of cubes, right? So we just have to see, is that a convenient sum of cubes? Is 64 a perfect cube?
Yes.
Yeah, it is. So we could write that as x cubed plus 4 cubed. And so what's that going to factor into? X plus 4
X squared
minus
4x
4x
plus 16.
plus 4 squared, which is 16, right? Make sense? Okay, you see how these work, right? We're just gonna look at these and see if they can be represented as one of those 4 patterns. Or 3 patterns, really. How about that one? What's the only one that could be?
Minus
It could be a difference of squares, right? Possibly. Well, is it? Can we write that as something squared minus something squared? What is the 25x squared? Is the quantity what squared?
5x.
5x. 81 is 9 squared, right? So what's that factor into?
5x plus 9.
Right? Okay. How about that? Okay, what are we gonna have to do there? There are no like terms, only 2 terms, they're not like terms. Okay, we could factor out the greatest common factor, couldn't we? What could we take out?
X.
So, and what's the sign of our greatest common factor gonna be? It's gonna be negative, right, because the leading term is negative. So we know we can take out front. We know we can take out at least an x squared, and it's gonna be negative. Is there a number part we could take out of this too?
3.
3 we could take out, yeah. Okay. So if we take out a negative 3, what are we left with then? 27, is that right? 27 x minus, right, because I'm factoring, if I'm dividing away a negative 3 from 24, what am I left with? Yeah, right, does that make sense? Okay, so then, that's, we got one factor out, that's good. What we're left with, does that fit a pattern? Okay, it'd be difference cubed, right? So we got negative 3x squared times what cubed minus what cubed?
3x
Minus 2. Okay, so then now we've got our minus 3x squared, our monomial factor that will just sit out front. And what's this whole thing gonna be? What's this gonna break down into?
3x, 2x, 3x minus 2.
Minus 2, right? Times.
3x squared.
Okay, so it's gonna be the quantity 3x squared though, right? So we gotta be careful about that. It's the quantity, because A is the whole, is the whole factor 3x, right? So the quantity 3x squared
Plus
plus
6x.
6x plus 4, and so then the last thing we'd have to do, and you can probably combine these steps once you start doing this a little bit, but what is that quantity gonna be when I square it out? That's probably the most common mistake I see on these, is people wanna write that as 3x squared instead of 9x squared. So that's our answer. Okay. How about that?
I got 3x squared and a negative 3.
Which pattern does that fit?
Some of that.
Okay, yeah, so that fits the one that doesn't factor, right? So that's done. That's as far as you can go with that. So what would you enter in the middle, do you think?
x squared plus 36.
X squared plus 36. And that's it. Oops. Okay, why don't you work a little bit? How about, huh?
Sorry, I'm gonna go put my notes, okay?